Today we're going to expand on our capability of solving equations to what are called systems of equations. Now, systems of equations are simply a set of more than one equation that works together. We might see this in a real-life situation where we have lots of things happening and we need more than one equation to model or show what's happening with all those. So here is our first system of equations. We've got two of them right here. These will work together, and when we find a solution, that solution has to work for all of the equations that we have, in this case for both of these. So our first task is to simply check. Now this is a matter of taking these x and y values, putting them in the equations, and seeing if those x and y values work. So we're going to go ahead and do that with this -4 and -2. For this first equation, we get -2 equals 2 times -4 plus 6. Let's simplify that. 2 times -4 is -8. So we get -8 plus 6, which is -2. And -2 does equal -2, so it works for this equation. Let's see if it works for the second one. So that would give us -2 equals -3 times -4 minus 14. -3 times -4 is positive 12. And 12 minus 14 ends up being -2. So we have, again, -2 equals -2. And it works for this equation. So this is a solution for both of these, which means, yes, it is a solution for our entire system. Let's check one more and see what happens if we change some x and y values here. So we're going to test this time 312. Up here, that gives us 12 equals 2 times 3 plus 6. 2 times 3 is 6. So 6 plus 6 on the right side is 12, and we see that 12 equals 12. So that works for this one. Let's check it out in the second one. That would give us 12 equals -3 times 3 minus 14. -3 times 3 is -9. And -9 minus 14 is -23. So we have 12 equals -23. That is not true. So this does not work for this second equation, which means this is not a solution for our system of equations as a whole. So our system has a solution here, yes, but not this one. All right, now let's take a look at a graph. We know from our experience with our equations and graphs that when we graph lines, it is simply a picture of all of the solutions that work for each of these. So when it's a system of equations, we can see that we have two separate graphs and there is only one point that works for both of those. It's right here where they intersect. So that's our first tool that we're going to use to solve systems of equations, is to graph the lines like we've been doing in the past and find that intersection point, because that's the one that works for both of those. Any other point along these lines doesn't work for one or the other of the lines. So let's take a look at our two equations that we have over here. Our first one we can see is in slope-intercept forms. We have our slope of -4/3 and our y-intercept of +1. So let's take a look at our graph over here. Our y-intercept is +1. Our slope is -4/3, so we're going to go down 4 and right 3, down 4 and right 3, and we could continue to do this if we need some more points. Let's take a look at our second one over here. This one is not in slope-intercept form, so I'm going to solve for y, and we're going to find the slope and the y-intercept. Let's subtract x from both sides. That gives us 3y equals -x minus 6. We'll divide by 3, divide both these by 3, and we get y equals -1/3 x minus 2. So our y-intercept is -2. And our slope is -1/3, so we're going to go down 1 and right 3, and we can see we have hit that point that is on the other line as well. So we have found our intersection point. It's right here. The coordinates of that point are 3, -3. So that is our solution to this system of equations. So there is only one place where these intersect. It's at the point 3, -3. This is our solution to the system of equations. So take the equations, graph them, find where they intersect or cross, and that will be your solution. We can take this, we can double check by plugging it in like we did before, but if we've graphed them right, we should find the correct solution. Thank you.